Hello, young scientists. So now we finally get to start the fun stuff. Over the next few lessons, we're going to be learning about motion, speed, and acceleration. You may have learned about these terms in previous classes, or if you've ever driven in a car, ridden a bike, gone for a jog, these are things that you have experienced in real life. Motion occurs when an object changes position. You don't need to see the movement happen to know that motion has occurred, right? If I'm standing at the front of the classroom and you close your eyes and count to 5 seconds, and all of a sudden I'm at the back of the classroom, you didn't actually see me move, but you know that motion has occurred because of the initial reference point of me standing at the front of the room. Distance is how far an object is moved. For the remainder of this class, we are going to be operating in the metric system. So that means the standard SI unit for distance is the meter. We do this because it makes all of our math a lot easier. We know that there are 100 centimeters in 1 meter and 1,000 millimeters in 1 meter, and we know that there are 1,000 meters in 1 kilometer. It makes our math a whole lot easier because you're just multiplying or dividing by powers of 10. Displacement is the distance and direction of an object's change in position from the starting point. So read that sentence and then look at this example. So it says distance can be longer than displacement, and displacement cannot be longer than distance. So if you look at this picture and you consider, say you're at a lake and your campsite is over here, and you want to get to your friend's campsite over here. There's a big lake in the middle. You don't have a boat, you don't know how to swim, so you have to take a long meandering trek through the woods right here. So that entire path that you took to walk from your campsite to your friend's campsite is the distance, whereas a direct straight line from the origin to where you're going is the displacement. The next term is rate. Rate is any change over time. And where we're going to see this a lot over the next couple days is in speed and velocity. Speed is the distance an object travels per unit time. So here we have the general equation. Speed equals distance over time, or abbreviated S equals D over T. So as an example, if you run 200 meters in 40 seconds, what is your speed? Here we have S equals D over T, or S equals 200 meters divided by 40 seconds. And doing the math, S equals 5 meters per second. Now, what I'm going to yell at you for the rest of the semester is every time you do a calculation, it's going to be worth 3 points. 1 is setting up the correct equation. 2 is getting the correct numerical value. And 3 is carrying the correct units through all the way. When we're working in physics, your units matter. 5 meters per second is not the same as 5 miles per hour. If you just put 5, I have no idea what you're talking about. You have to carry your units all the way through. Now, I've spoken to your math teacher, so I know that you know how to algebraically rearrange equations. So the original speed equation is S equals D divided by T. This can also be rearranged to solve for D or T. So S equals D over T can become distance equals speed times time, or time equals distance over speed. I'll print one of these out for you, but this is just another way of looking at it. So whatever you want to find, say you want to find distance. You cover up the distance, and S times T will give you your distance. Or, if you want to find speed, you cover up speed, and distance divided by time equals speed. And last, if you want to find time, distance divided by speed will give you your time. So like I said, I will print this out. It's just another way of thinking about it. And hopefully there's not a whole lot of confusion on that.